2D collision. A ball of mass 0.25 kilograms, that's M1 right over there, is moving at a constant speed 1.8 meters per second on a horizontal frictionless surface. Now this is a top-down view. That's what we're looking at, bird's eye view. It collides obliquely with a ball of mass M2 at rest. The velocity of the first ball after the collision is 1.2 meters per second at an angle of 38 degrees with the dashed line. What is the velocity of the second ball? So we're going to want a magnitude and an angle. And again, we're looking top down on this like we're watching a game of pool. The problem doesn't state whether we have an inelastic or elastic collision. Does that matter? Nope. Momentum is conserved in all collisions. So we have P1 plus P2 is going to be P1 prime plus P2 prime. So this up here, this of course will be P1 prime for mass 1, and this will be P2 prime for mass 2. And then you break out what momentum is. Of course, it's just mv. Let's write down the components of the momenta as we see from the picture from the sketch. So we look at the diagram and we see that mass 1 has momentum in the x direction, and it's m1 times v1x, 0.25 kilograms times 1.8 meter per second, and we get there's our initial momentum in the x direction. P1y is 0 because it's just moving in the x direction, and object 2 has no momentum at all, so it's 0. So let's go ahead and resolve P1 prime now into its x and y components. Okay, so now we've done this on the left side. Now we want to do the post-collision, or the after. And we know that P1 prime, well, let's see, what are we given? We're given the V1 prime right here, and of course the mass is still the same. So what we're going to want to do is find the momenta here in the y direction and here in the x direction. So it's just a little trig there. So P prime 1x is the mass times 1.2 meter per second, that's its velocity on the angle, times the cosine of 38. And we get this. And we'll keep an extra sig fig there until we get to the very end. And then P prime 1 y, that's the sine function, and there's our number. So we've got this one all taken care of. So we're going to move on to M2 next. For conservation of momentum, we know that it's conserved separately in both the x and the y directions. So let's look at the x direction first. Our initial momentum is solely due to mass 1, right? Mass 2 is 0. Then afterwards, here's our new momentum for mass 1, and we have to find the momentum, the post-collision momentum of the second sphere. And we can just solve that little simple algebra there, and we get P prime of 2x is 0.214 kilogram meters per second. Now let's look at the y direction. Our initial momentum in the y direction is 0. Nobody was moving there. But now, afterwards, we have this momentum here. Well, that's the velocity times the mass times the sine of 38, which we solved on the previous slide. And that was 0.185. And since it was in the up direction, we're going to call it positive. And then we add to that P prime 2y. The sum of those have to equal 0. So we now have what P prime 2y is. So we're almost done. We've got the components, the momentum components of mass 2 after the collision. Now we go ahead and use Pythagoras and also the inverse tan, and that will find our final momentum of 2, P prime 2, the second sphere. Then we divide it by m2 to find the velocity, and finally we'll reduce to two significant figures at the end. So right here is our momentum. It's P prime 2x squared plus P prime 2y squared. We substitute in the values from the previous slide, and we find that P prime 2 has a magnitude of 0.283 kilogram meters per second. To find the velocity, we just go ahead and divide by its mass, and we get 0.86 meters per second. We cut that down to 2 sig figs. To find the angle it makes, okay, so it's going to come off in this direction here. We're finding this angle, well, we called it theta. We'll call it theta. That's the tan inverse of p prime 2y over p prime 2x, right? This right here is the y component. This is x, so tan is opposite over adjacent. Put in the numbers, and we get a negative 41 degrees. So that theta there is 41 degrees, and the magnitude is 0.86 meters per second. And just to summarize, we put the angle here, 41 degrees, and that's, this angle here is 41 degrees of the second mass bouncing off, and here's its final velocity of 0.86 meters per second.